Our guest speaker for tonight is a full-time faculty member of the Computer Engineering Department at the College of Engineering of Adamson University. He is a certified research and development project manager accredited by the American Project Management Association. So I'm now giving the floor to Engineer Dylan Lopez. Hello, sir. Good evening.
Hi. Hi everyone. So I just fixed my mic there. So, hello RPA Philippines, and thank you for having me. And I'd love to introduce to you this wonderful field that I am very fond of. For a few years now, I am doing research and doing actual industry consultations with this. It's the field of artificial intelligence. Now, I'm sorry, I'm just going to turn off my mic while I'm going to present to present our topic for tonight. So forgive me for that. So my stream would be all well because my internet's a bit unstable. So sorry for that. So hi. So I'll see you later see you again at the question and answer portion. So allow me to share my screen. A little bit of more background about myself. I'm doing AI research now for 4 years. So I've been doing this since undergraduate studies. My focus is actually in the surveillance systems, computer vision, or what we call robotic vision. And I also major in sustainable artificial intelligence. So I just want to know a bit of survey here. Anyone here has worked with any type of artificial intelligence? Please just raise your hand. Great, great, great. We'll have that. How about anyone here? Raise your hand if you have heard about AI before. Might it be from anime, K-drama, or in the news? Great. So that's great. That's great. So we are going to talk about artificial intelligence today. So for those, this will not be a bit more technical side, although I'm in the academe. Don't worry, I will not talk too much of the equation side of artificial intelligence. Let's talk about the bright side, actually the dark side as well, of how should we perceive artificial intelligence? All right, let's move on. So what is AI? So some might say it's love, but for me, yeah, it is AI. But AI here is artificial intelligence. And according to John McCarthy, one of the founding fathers of artificial intelligence, so you can read this whole block of text, but the summary here is that artificial intelligence is a biomimicry. It's a type of science and engineering that focuses on mimicking human minds. How do we think? How do we feel? And that's the goal. And how do we interact with the environment? So it's really just like making like humans or making a brain, okay, out of code, out of equations. And so again, that's very simply that AI is just the ability of machines to think and learn like us. Simply that's AI. It's not some sort of overlord that's going to take over the world. And we're going to talk, there's actually that question later on we're going to answer. So AI has three types as of now. One is what we call the artificial narrow intelligence. We have artificial general intelligence and artificial super intelligence, right? So ANI is what we call weak AI, but it's not necessarily weak or useless. These are AIs that are programmed to do a specific or single task. So just like passing butter, okay? But it could also scale into like driving cars. Self-driving cars are example of artificial narrow intelligence, and their sole purpose is driving a car. Chatbots are, of course, ANIs as well. Recommendation systems that you use in Spotify, Netflix, and Shopping, Lazada are ANIs as well. But you can see they're not necessarily useless type of artificial intelligence. And we have AGI. So AGI is more of the sci-fi type of artificial intelligence, but take note, it is ongoing research. This is what we call strong AI. So these are AI that can think, learn, emote, and do self-awareness, right? So these are probably those who have watched in TV, for example, Space Odyssey 2000, Tau, if you have watched in Netflix, that's a good recommendation as well. Ex Machina, those are examples of strong AI and actually leading to ASI as well. So as long as the artificial intelligence is capable of learning, providing emotion, or doing empathy with people, that is the goal of AGI, right? But now, as we go to artificial superintelligence, now these are AIs that have surpassed human capabilities. And this could be in any or all aspects of being a human. Might it be cognition, trying to think, answer a question, provide emotions, or even, predict the future and act upon it, and even control multiple states at once. So that is the dream of artificial superintelligence. But take note that there is something really in the sci-fi world, unlike in AGI, we do have researches as well already going, especially in the UAE. There's a lot of AGI going there. But ASI, not yet. I'm not saying not completely because humans do tend to become very curious in doing such innovations. And the main constraint why ASI is not realizable as of the moment is, of course, technology. Our software could have the capabilities to adapt to this, but not the hardware. So our hardware is limited. We only have CPUs and GPUs so far. You can have a whole farm of GPUs, but you can't still make any type of ASI. Our quantum computers are still on the way, although we are have functioning quantum computers, but they're not really in that scale in providing great technological advantage in terms of superintelligence. But this is now still a dream for us. All right. Okay, so the image is not found. So what are the myths of AI? Let's start with that first. I'll just answer the FAQs that I have so far from the number of talks that I have with AI. And here are some that I have got that probably is going to answer some of your questions. So first is AI is being superhuman. Okay. So some would say that creating artificial intelligence grants humans superhuman powers or intelligence, just like in Neuralink, right? So this is a myth for a reason. So no, it's more accurate to say that AI, on the aspect or the mantra of why do we develop artificial intelligence is to make automation realizable in the human level. It is putting all the menial tasks of humans, just like in general robotic processes, right? To make human tasks easier and automated by everyone. And AI just brings that to a further level. For example, reading, comprehending. Those are tasks that can be done with normal programming or normal automation. But AI grants that kind of process to humans so that we humans could do other things better, just like management, focus on creativity, focus on empathic skills, all of those things that an AI could not do or any type of robot could not do. So we can focus on those, and all of the other menial and repetitive tasks could be for the AI. And there's what we call a human level performance, or HLP. So the goal of any industrial grade artificial intelligence is to reach human level performance. Now, there are some on debate that exceeds human level performance. But what we need in the industry is just human level performance because we just want to put that task to a certain automation. And in that case, we don't want to problem or to stress ourselves that we are creating something revolutionizing that's going to take over the world. Not that is not realizable for something that you can get from GitHub or something that you will download as an API. Not really as such. But HI alone is still a work in progress. So we can't just realize that, we'll be very scared that this will happen. Okay. So much more with ASI. So we can't really go into that right yet. Okay. So that's for the first myth. Second myth is AI is just pure if-else statement. So you might have seen this meme all around in Twitter or in Facebook. So, all right, I actually am quite offended by this because I program artificial intelligence from scratch, and this is not an accurate depiction of what I do for a living. The truth is, um, AI is biologically inspired, just like John McCarthy said. It is derived from laws of nature and human cognition. So think of all the works from the 1950s that people are trying to create equations out of your neurons. I mean, the literal neuron in your brain was modeled into an equation. And that equation 20 years later was programmed and used to do machine learning. And that is quite wonderful if you could see the transition of technology from a simple philosophical idea to programs that you are using right now and taking for granted, just like Omegle, or not Omegle. I remember SimSimi is a form of AI that was really abused by the people. And yeah, it's quite sad for researchers and some industry practitioners of AI that what is the form of AI right now. But anyway, so take this for example. This is one of my favorite algorithms in AI, which is the convolutional neural network. So I'll spare you all of the details here of the mathematics, but it is inspired by your visual cortex in your brain. It's really directly derived from your neural in your visual cortex, right? So from V1, V2, V4, all of those areas in your neurons are actually transcribed. And those ideas are transcribed into the developing of convolutions as operations and later on program. And this simple algorithm revolutionized every AI in the aspect of computer vision that you are probably using right now, from your filters in IG, those use convolutional neural networks, to object detection systems from drones. And all of that was derived from the idea of biology and later on mathematics. You know, I believe in 1953, uh, Hubel once created an algorithm that converts this, actually transcribes the idea of the visual cortex from the cat's brain. Okay, you put probes on a cat's brain and see that there are observations on the levels of complexity of how would a cat see a certain image that starts from outlines to segments of lines to shapes, then to complex ideas in your brain. And that's a very complex matter that takes years and decades of research. And it's very sad to say that if people just thinks about it as if-else statements. So it's really saddening for us. So there is big complexity behind all of the APIs that we have been using so far and all of that hard work through the years. And you can see that convolutional neural network is now coded as something like this. This is now in Python, if you're familiar. It's coded in TensorFlow. And how would you code a convolutional neural network? It's actually simple this time. And a few years back, this was actually quite convoluting, a convoluting convolutional neural network, right? So yeah, it was from those complexities it came to this. And it's not easy coding because there's still math behind this on how we configure this neural network and what's behind all of those filters of yours. So it's no joke. It's not if else. So that's offending to AI engineers out there. So please don't say that. So, however, there is a type of artificial intelligence that utilizes if-else statements, but not entirely if-else. That is expert systems. This is a very old type of artificial intelligence. Take note that AI is not confined to machine learning. There are other fields such as evolutionary computations. We have genetic algorithms, and of course, expert systems here. Now, if you think how did the games back in the day, for those here are quite well versed in the games. For example, the very old um, not very old because I'm going to show my age there. Um, Age of Empires 1 is an example of, of AI that uses expert systems and yet alone statistics before the dawn of the prevalent use of machine learning. So they use heavily expert systems. So from if, else statements, and or those are the first styles or first ways to develop AI. But those are no joke because there are formulations of propositional logic. If you took some philosophy class or logic class back in college or high school, if you heard of it, those are actually translated into code. And those have proofs of mathematical proofs, and those are still no joke as if-else statements. So yeah. Connected to this is another myth. In contrast, is some would say AI is code that adjusts itself. All right, so that is quite powerful. So some would say AI is a super software that can fix itself on its own. That is quite promising, but not really. So that's not the case. It's not. But let me be clear. It's not always the case. But there is an application of artificial intelligence that could do that. Okay. So there's this paper. I believe this is from Stanford University as well. There is self-adjusting programming. So AI could be used for such applications, but AI itself is not. So we still manually code those things, and we try to debug those programs. We try to modify those parts there, and yes, we use statistics and mathematics in some parts. So that actually is the AI behind that. But you can use AI to create another AI that adjusts itself. So there is another type of AI that adapts the programming styles or the work processes of other people. So it's just like a project manager AI, wherein I believe that's way back in 2014, wherein they had this type of PM AI where they took freelancers from all around the world, they hired them, paid them, and that PM AI manages all of those freelancers. Those are coding freelancers, by the way. So they're trying to create a system or a very simple information management system. After that, the AI actually learned on the coding styles of the different programmers that they have freelanced. And that alone taught the AI to code for itself and adjust its code and later on create its own project. So there's that one application that's actually scary if you think about it. Okay. Another type of myth is, AI is entirely autonomous. So for others who, of course, you don't, if you still don't know the difference between automatic and automatic is that there is still some sort of human intervention, while autonomy is completely without human intervention. So AI is completely autonomous. So not entirely, actually. So it can't modify its code, but it should learn automatically. That's the notion of some people, but not really, not entirely the case. So this is true for AGI, but not for artificial narrow intelligence, which comprise the majority of all innovations right now in artificial intelligence. Oh, oh, sorry. What is this? Stop sharing for a while. Sorry. We know what happened there. Right. So there is what we call supervised learning. So this is one type of artificial intelligence that you are, supervising the learning process of a machine learning or an AI. So it's learning through what we call examples. So you feed data into the model and you are telling it what it should be. Okay. It's like teaching a child, like, okay, I have a family photo album. You are teaching the baby that, okay, this is mommy. You show the other picture, this is daddy. Show the other picture, this is your ate, this is your kuya. And that's supervised learning. And there's a certain process that we do that as well in machine learning. So there's the response, or what we call the what data that we have, or the target, like who is this, but with the picture, and the stimulus there is the label. Okay, who is this? This is mommy. So that's the label of the data, and we feed that into machine learning or an AI, and it tries to keep on learning from itself. Okay, and the baby would just say okay, and points that okay, this is daddy, this is mommy, and this is ate. That's correct, and that's a good point for the kid, right? The same thing about AI. It's just like a kid, like you're trying to teach. So yeah, that's the aspect. You're still supervising the learning of the AI, and you need to engineer your way to make a very good artificial intelligence. There is also what they call unsupervised learning, like most of us would actually experience back in college. They're just going to give you materials, then learn from it. Okay. And unsupervised learning is actually a very powerful tool. You're just going to feed data, and the output of an unsupervised machine learning or AI, it's going to automatically find patterns for you. Say, for example, find clusters between customers. Which group of customers does this? What are the customer behaviors like that? In my case, I do teach, so I use this to find instances of cheating. Like it depends on the time and the score of the students. I forgot to put that in slide. But if you want to know more, I do have a full report about that on how to find cheating using unsupervised learning. That's actually something I would do when I was trying to spot and the first time I was teaching in the online setting. So yeah, unsupervised learning, you're just going to feed the data and the AI will just tell you, okay, these are the groups that is present in the data set that you have given that. And there is the reinforcement learning, okay? I think this is one of the famous AI around there, especially with robotics. So reinforcement learning is a type of AI that you are going to deploy into a certain environment or a certain field. And that AI would try to interact with the environment. And you're just going to set what would be the objective of that artificial intelligence. So say for example, you are trying to build a robot that could try to walk on its own. So the objective is the most distance from your position right now to the other side of the room. And the reinforcement machine learning would help in try try to help the robot move around with all of the possible actions it could do, like move its legs or struggle around until it goes to the goal. So it also uses, just like in psychology, the aspect of reinforcement learning is rewards and punishment. So if the robot did wrong, then you're going to bonk it or do some punishments around for the robot. But if it's right, you are going to reward it. Okay. And the goal of any reinforcement learning is to maximize reward. And after you get a maximized reward for a certain action or for a certain activity, that is what we call an optimized policy given a set of actions. So when I say optimized policy, this is the same thing as the best way to do something. Okay. So in that sense, it's what we call an optimization algorithm. It's trying to find the best combination of things. Now, this could be used further in business, such as what would be the best combination of food for a certain menu. Other thing for supply chain management is how many distributors should I actually place so that I could meet the ends for my customer delivery and the cost that I have. That's one thing. In terms of, for example, construction management, how many materials should I buy given the amount of budget I have and considering also the strength of the materials. So all of those questions could be optimized, minimized, or maximized by reinforcement learning as an optimization problem. Okay, so if you're interested about that, it's actually a very great field to dwell in. But in that sense, not all AI could autonomously learn just like reinforcement learning. Some would still require your supervision and try to engineer some parameters, and they would at least require you to feed some sort of data that you have collected or some sort of algorithm that you have developed or pre-hand. Right? So I hope that helps. Okay. So, and lastly, will AI take over the world? So AI is evil. It will take over humans in the next few years. Okay, so some of you might have that misconception, and as a person in the field, that's actually not true. If you think, however, that AI will take over the world, just like in Civilization 5, is domination, like world domination, like they are going to conquer every country and pillage every village. No, AI will not do that, provided that we have policies, and ethics guided with us. However, if you think about it, if you change the idea or the philosophy of taking over, um, you might actually get what you want or make that myth come true. If your definition of taking over the world is not by means of domination, however, by means of economy, that could be possibly true. The economy could be run by AI, given a certain level of degree, or it could even take over jobs, just like what is happening right now. Or it could take over behavior of people, that people are going to rely too much on artificial intelligence that they could not create decisions on their own. In that sense, that myth could be true if people like us would be hyper dependent, not just super hyper dependent on artificial intelligence, just like, without that we will not live, just like air, you know. In that case, that will be, granting that myth to come true. And that is not really impossible. Basing on the behaviors of humans do tend to have that kind of behavior. And this is something alarming that could happen in the future. And, you know, academics, researchers, and even industry professionals should be wary about that. And this now actually in the psychology of, the user experience in artificial intelligence. Okay. I'll answer that question. That's a very fun question to answer. Let me just finish the powers of AI and some ethics here. I'll just go through fast so that we can entertain more questions. So one, there's my field is the areas of applicability in robotic vision. So as you can see here, there's a lot of ways. Self-driving cars, all about cars right here. Traffic violations. There's also counting of cars in traffic. There's also, identification of cars. And actually, this one right here, it's an object detection model that's run on a UAV, and it tries to differentiate trucks from cars. And that's cool. Okay. There's also natural language processing. So there are AI that could translate, of course, language. There's ones that can translate from hand gestures to words, just like we see in the news. And there are content generation AI. So if you, for example, give an artificial intelligence some sort of data, it could try to replicate some content based out of that. And that's not only words, it can also be in images. And that's actually the worries of deepfake for those who know that. There's also time series analysis, of course, Forex, um, stock predictions. Yes, AI could do that for us as well, but not to the extent of like how brokers would do that or day trading would do that. There's a lot of considerations, and you would need to have lots of data. And there's, of course, weather prediction. Your weather prediction right now is one of the most common applications of artificial intelligence. How do they know it's going to rain tomorrow, right? So they use time series analysis on the previous days and the previous years and the current parameters like right now, like wind speed, temperature, humidity, and all of those things. There's also recommender systems, of course. I believe everyone here has experienced this in some point of their lives right now. Netflix, Spotify, your weekly discovery, those are actually examples of recommender systems. And recommender systems could also appear in ads, just like everything that you have done in Shopee could, or everything that you have searched in Google could also appear in Facebook. And and how do you think that happens? They use a recommender system in trying to predict your behavior, and they could actually map that out, predict what should you do next, and you help actually in doing that. Facebook also use this in their UIs and UX. So the length of how would you stare at a post or interactions and comments to a certain post, for example, gives rewards or adds a feature to your digital personality. And that in that sort of data, they will use that for building a model that is best for you. That this will rightly predict what is your behavior on Facebook, and they will just feed you the best ads and best content for you. And it is notoriously implemented right now in their new updates. And most posts now are suggested for you, and that's based on your previous interactions. And that's actually scary and amazing at the same time in a technical perspective. There's also business value. Of course, there are AIs that could help in onboarding and generally the HR process, automation in manufacturing, of course. There's also again, in the manufacturing field is quality assurance. Right here, it can be done in other supplies, such as in what do you call this, in bottling industries, and of course, semiconductor industries here. There's also powers in societal impacts, and actually in my field right now is building better communities, urban development. AI could help in identifying which areas of your city could be built new skyscrapers or which one should be best for farming or parks. And that kind of AI is really revolutionizing the way we live right now. Mostly in other countries, but not yet in the Philippines. But that's the dream. There's also the impact of identifying, of building communities in terms of social analytics, trying to understand what you're trying to say, trying to find fake news, and there's what we call complexity analysis, trying to find who your friends are and how connected are you with each other. And there's an algorithm that could predict who would you be interacting in the next few days, and that could also be helpful and harmful in some other ways. There's also, in the health aspect, sorry for the title right here, that you could use AI to detect even COVID-19 patterns in your lungs. This was actually in 2019, but now, of course, this would be different since we have a different variant. And here's what I have been doing for the past years. I am working on violence detection and crime detection. So that's my field of expertise in computer vision. I try to identify would there be a crime or not. There's could also be works here that could identify whether you could shoot a gun or a possible anomaly in society. So those are the fields that I've been working on, and these are really area of concerns in the Philippines. And of course, there is AI for the disadvantaged. AI that could build communities through helping out the blind people and trying to identify hand sign languages that could help us understand them better. And there's also, of course, AI for environment. So there are AI that could detect whether there would be instances of deforestation or whether what is the status or the health of a certain ecosystem in the rainforests. There are AIs, of course, detecting garbage, segregation, and even the transportation of trash. And of course, there are for agriculture. So how could we help the environment or in the farmers in identifying whether their farm crops are doing well or not? And this is very impactful field. And let me now move to ethics right here. What are the precautions that we need to take when we are going to talk about AI or implement artificial intelligence? First is data bias. So when you talk about data bias, these are bias in how do we collect the data or the data that is being fed to the artificial intelligence. So this is another recommendation I'd like you to watch in Netflix. It's called Coded Bias. So whenever a machine learning or artificial intelligence would ingest data, whatever quality of data you're trying to feed is what you get. So garbage in, garbage out. Whatever trash that you feed to a child is going to be a trash that's going to do against you. So this is something that it's also affected in artificial intelligence. Whatever you feed to an artificial intelligence is what you get. So you need to be very careful in how would you do this. So say, for example, like this. So one precaution that happened is Uber way back in 2018, trying to do your test drive for a self-driving car. But that model of theirs failed to recognize patterns of certain people, such as people with from the African descent or dark-skinned citizens. So it failed to detect that as in the times of dark or in the nighttime, and it accidentally killed the person. So that's data bias because the AI was not trained to recognize that kind of data, it will not respond to that data. So for example, here again, using Michelle Obama's picture using Microsoft AI's face detection. So it tries to annotate the image as a young man wearing a black shirt And the confidence here, that means what is the probability of this being right? The AI believes it is around 80% correct. Okay, so that's quite alarming. So let's now have Oprah Winfrey using Amazon's face detector. So it appears to be male with 65% accuracy, right? Or 65% that the AI is sure this person in the picture is a man, and that's just not right. So whatever you feed to the AI will just be the output or be the expected output. You can't just expect it to be smart. You still need data in building artificial intelligence. Next one is human bias. So whenever we talk about human bias, is actually looking at how would you train the data and what is the belief of the researcher. So this is now actually what we call as researcher bias as well. If the researcher does not believe that the data set should include black people, then that's a problem. If the researcher would not believe that your data should include people of indigenous descent, and there's a problem. Okay, so we need to become ethical as well as engineers, as professionals, when tackling AI. For example, here, this is one of the disturbing results of AI in the recent years. So they created a deep neural network, an artificial intelligence that would accurately um, detect your sexual orientation from images. And this is what we call the gaydar. And it's quite offensive, of course. And these kinds of researches are good at some point. However, not to the extent that it could be used for prejudice. So it, or even stereotyping people or profiling people without their consent, or that is legally right or ethically correct. So these are things that we need to consider in the ethical level of doing artificial intelligence, both in data collection, training, and the belief of how would we implement our automations. So there's a last thing here is AI fairness. How do we balance everything? So we need to look at both societal and technical aspects of the impacts of artificial intelligence. Not just maybe this, but generally automation. So for those coders out there, you might need to look at FairLearn. I'm not promoting, but this is a open source community-driven project that will help data scientists, machine learning engineers to improve the fairness of AI systems, to balance the societal and technical aspects and impacts of AI. So there's a case study here if you want to check, but you can visit fairlearn.org if you want to go. And I believe that's it because I really want to answer your question. So sorry for speeding up things. So thank you, and I hope that actually helped, and I piqued your interest in artificial intelligence.